poppin' YouTube? Code adventurers, welcome back to the Advent of Code 2023. It's Chris here, and last night we scratched our way through the scratch cards, making copies without actually duplicating anything. Just another day in the coding wonderland, I guess. If you missed that action, catch up, because tonight we're diving into day 5, and I'm ready for another coding adventure with all of you. I hope you got your coding gloves on, because things are about to get hands-on. As always, if you're not part of the Code Adventure crew yet, hit that subscribe button, give it a like if you're ready to tackle tonight's challenge, and ring that bell to stay on the loop with all things Advent of Code. Now, after successfully navigating through scratch cards, I'm buzzing with excitement to unravel the next puzzle. So grab your coding tools, clear your digital workspace, and let's jump into the code for day 5 of Advent of Code 2023. Are you ready to crack the code together? Let's make it happen in 26 seconds. Day 5. If you give a seed a fertilizer, you take the boat and find the gardener right where you were told he would be, managing a giant garden that looks more to you like a farm. A water source? Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it. Can't make snow with dirty water. Don't worry, I'm sure we'll get more sand soon. We only turned off the water a few days, weeks. Oh no. His face sinks into a look of horrific realization. Horrified. I've been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island Almanac just arrived, and we're having trouble making sense of it. The almanac, your puzzle input, lists all the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number, but numbers are reused by each category. That is, soil 1, 2, 3 and fertilizer 1, 2, 3 are necessarily related to each other. The almanac starts by listing which seeds need to be planted. The rest of the almanac contains a list of maps which describe how to convert numbers from a source category into numbers in a destination category. That is, the section that starts with seeds to soil map describes how to convert a seed number, the source, to a soil number, the destination. This lets the gardener and his team know which soil to use with which seeds, which water to use with which fertilizer, and so on. Rather than list every source number and its corresponding destination number one by one, the map describes entire ranges of numbers that can be converted. Each line within a map contains 3 numbers: destination range start, source range start, and the range length. Okay. I'm not sure if I'm confused yet or not, so we're going to keep going. Consider again this example seed to soil map, 1592.8. The first line has a destination range start of 50, a source range start of 98, and a range length of 2. This line means that the source range start at 98 and contains 2 values, 98 and 99. The destination range is the same length, but it starts at 50, so its 2 values are 50 and 51. With this information, you know that seeds number 98 correspond to the soil number 50, and that seed number 99 corresponds to soil number 51. Okay, so it's a 1-for-1 map, but it's like a range. So seed number 98 corresponds to soil number 50. Seed number 99. It's a seed to soil map, but the soil is the first number and the seed's the second. don't know. I don't necessarily like that, but okay. It's backwards. I think that's done on purpose, and I'm just going to hopefully remember that. So the first line has a destination range start of 50. Okay, so this is just going to be 50 maps to 52, 51 maps to 53, 52 maps to 54, so on and so forth for 48. Oh, I guess they did mention that in the mapping, a seed number, the source, to a soil number, the destination. Okay, so I understand that. Any source numbers that aren't mapped correspond to the same destination number. So seed number 10 corresponds to soil number 10. Okay, that's spicy, but easy. If we just go ahead and populate the maps, 79 corresponds to soil number 81, 14, because it doesn't exist, 55, 57. Gardner and his team want to get started as soon as possible, so they'd like to know the closest location that needs a seed. Using the map, find the lowest location number that corresponds to any of the initial seeds. To do this, you'll need to convert each seed number through other categories until you can find its corresponding location number. In this example, the corresponding types are seed, soil, fertilizer, water, light, temperature, humidity, location. So the lowest location number in this example is 35. We can go ahead and start here. This is going to be a doozy. I maybe not. Maybe I'm overthinking it already, but a couple of things come to mind. This isn't particularly hard to map and create. So to store the data, I guess, more efficiently, they give a range. So you could pre-process this and create all the maps. I'm going to actually take a look at the input ahead of time, just because I could just go and create all these maps, right? There's not that many seeds, and I could expand all the maps, but look at the size of these numbers. So I feel like while that approach would probably work, I'm going to spend a whole lot of time looping in creating these maps. So what other approach can we take? So if I have seed 79, there's not a whole lot of actual mappings, right? So I think we can keep this compressed, and what we do is really, maybe this is going to hurt me in the second pass through this by not doing the maps, but I'm just going to fight against the maps, because I think, you know, if you look, it's like, okay, I'm going to loop through all of these, then I'm going to create these arbitrary like indexes. I just don't think it's going to be particularly efficient. So what I would rather do instead is create essentially a set of 3. And what we can do is, if we have a number like 11, 8, blah, 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 we can just loop through this slice pretty efficiently, and we can check to see all of the ranges. And so what we'll do is we'll check the range of this to this plus this. And if it's within that range, greater than or equal to or less than or equal to this range, then we know that the seed is in there. And we can take our number, like, I don't know if that first one matters, but if it's in this range, we can take the number, subtract the bottom number, and that'll give us our value. And then to get what number it needs to be in here, we can look at the difference here, whatever that is, plus our difference. And so we don't actually have to use a map. And I feel like because we only have a few set of seeds, I think that's probably the better way to approach it. So we're going to create a seed to soil slice and a slice of slice-ins, and they'll be split. And then I think that'll be the efficient way. If we take the other approach, which is a little bit more brute force, the amount of data that you're just going to be storing in memory, I don't think is going to be super efficient, and it's just not necessary for solving part 1. So let's go back to our small example here. So what am I talking about doing? We'll walk through it. You guys know I'm not fast with these, so we'll just walk through it. And if you want to skip ahead, skip ahead. So seed 79, what we're going to do is we're going to take this, and there's a special rule that said any source number that aren't mapped correspond to the same destination number. So seed number 10 corresponds to soil number 10. So let's look at seed number 79. Seed number 79 needs to be, let's just make sure, source category, into number, and a destination category. So seed to soil map, again, let me just make sure it's source. The destination range is the same, but it starts at 50. With this information, you know that seed number 98. So in this, the seed number is the second number, and the soil number is 50. Okay, or so is the first number. So we know that this is the seed. So we've got 50 to 50 plus 48. So that's 98. Okay, so if we have 50 to 98, so 79 fits into that category. I knew immediately it's not between 98 and 100, so it's going to fit into the second one. So we know that 79 is our seed number, or it's in this range. So if we do 79 minus 50, that's 29 difference. We know that it's in range, so to figure out what soil it goes to, it's just going to be 29 plus 52. That's 81. So seed 79 maps to 81. So while we're not going to store it in a map, we're going to be able to ascertain for a given seed what its value is just by handling these ranges. We're not going to use maps at all, which I think is kind of what they're trying to get you to do, or lead you down a path of pain. So let's not have pain. All right, so what are we going to do? For each of these, how do I want to split this up? I want to split this by double return. So what we're doing here is we're saying anytime you see two hard returns, that's our delimiter. So we should end up with seeds, seed to soil, soil to fill, so on and so forth. So we'll end up with each chunk, and we're just going to go ahead and we're just going to print those lines out real quick, and we're going to run our test, and we're going to see what they look like. Okay, perfect. So those are the chunks we want, I think. Let's make sure. Yeah, let's make sure. So I just wanted to put the word line in front of it. We'll go with split here, and we'll put our hard return here. Okay, so now we've got each of our sections, and we know we're going to need a couple of things, at least for part one here. So what I'm going to do is I'm just going to put, and we're going to create a couple different slices. And so the first one is just going to be seeds, which is simply going to be a slice of int. And we're going to have to parse all that out and make it ints. We're going to go ahead and do that while we pre-process this data. We'll call it soil to fertilizer. And same thing, ints, except that's a slice of int. So slice of int. So that'll represent slice 0 with the slices of that being split, etc., etc. So we've got that, and then we're going to need fertilizer to water, and then we're going to need water to light, and then light to temperature, and then temperature to humidity, and humidity to location. Okay. We'll go ahead and initialize all of those, and we'll handle these further down. I suppose if we're doing somewhat proper Go syntax. This will be that. This will be that. And this will be that. All right, cool. I think it'll be easier if we break this up into two funcs here. So we're just going to do func get seeds, which is just going to be a string. And we're going to return our slice of ins. And so what's going to happen is, sort seeds anywhere else in here? Seed to soil. No, it's just seeds. Okay, so what we're going to do is just, again, kind of crazy, but case, actually switch on. We'll just do if, and our line is what we care about, and the word we're looking for is seeds, like that. If that's true, we're going to call get seeds, and we'll call it seeds equal get seeds, and we're going to pass in the line. And we're going to go ahead and strip off the seeds while we do that. Seed space. And that's what we're going to pass in. Replace, we'll just do replace all. Okay. And that'll give us our seeds. So what are we going to have in seeds? So seeds is going to look something like this. So that's pretty straightforward. We're going to do strings dot split s, and we're splitting on an empty space. And then we're going to say for and we're going to say ins. We're going to convert the a to I. We're going to convert the value, and we're going to get back an int and an error, and we're just going to say panic error, which I would never do, ever do in the real world. But because we're here and we're adventuring and we're willing to take risks, we're doing it. Okay. And then return ins. Got it. So okay. VS Code's bugging out and I can't click the run test. I could just run test a different way, but I want to run just this one. Okay, well, I know that they're declared not used. Thank you for helping me, VS Code. You're my friend. I mean, we can just expand it. That's fine. Okay, cool. So we got our seeds. That's perfect. That's exactly what we want. The rest of it's pretty straightforward. So similarly, but we have multiple lines to process, right? You know what we could do? We could just make a map of all the int-ins, the slices rather, because at this point I already have the name. I could pull the name out. We already know the rest of them are our values. And we can just extract it, and then we don't really have to worry about all of this. So I think I'm going to do that. So if it doesn't contain seeds, right, then we know we have a map, which is the other section of data that we have. So let's extract the name. Yeah, so we've got seeds to soil, right? Look at our test, it's right there. So we just got to split the first line. So this is what we're going to have. We're going to have a map of string to slice of int. And so then we're going to put this name in the map. So instead of having all these other slices, we'll just construct it based on our input, and then we'll have our maps done there. So what we're going to do then is we're going to do strings.split. We'll just build it here. Maybe we'll put in a function later, but line and how do I want to do this? So I can get the name out pretty easily, but we need to iterate through each line in the section. So what I'm thinking I'm going to do is we're just going to split this actually instead on /n first. So that's like the mappings, and then mapping sub 0 strings dot split mapping sub 0 on that sub 0. So what I'm doing is I'm basically putting all of these into an individual slice, and then I'm saying take the first one, which doesn't have the word split in it, take the first one and split on this space and grab everything to the left. So that gives us our first value, which is our name. And so everything from that point forward is going to be mapped into that name. So now that we have that, we need we're just going to do a good old fashioned I is less than length of mappings I++. So that way it will iterate through, and then we'll say I is not 0, it's going to be 1 because 0 is the header record. And then we are going to change this to getins. We'll make it a little bit more generic. So getins. Okay, so what I realized we could utilize this here. So then we're going to do a getins on the rest of the data, but there are multiple lines. So the one difference here is that we're going to have to say ints slice. Oh, wait a second. No, this is fine. This is fine, because what we're going to do is this. We're going to do maps. Okay, maps sub name equal to append maps sub name get ints mappings sub I. Boom. Okay, so what this is going to do is on the first line, which is line 0, we're going to get the seed to soil out, allegedly. And then on the first record, or index 1 rather, second record, index 1, which will be here, we're going to run that same get int. So we're going to append it to the map for the name that we have. And then we're going to keep appending to it. So I think we're okay in Go. We may end up with like an uninitialized thing here, and I might have to figure that out, but we're going to give this a shot. So what we should have here, we'll get rid of this, and we'll just do a printf, and I suppose we could have done just the print of it, but this is fine. Maps. We're going to go ahead and see what that will produce in our test before we move any further. Okay. I think what it's doing right now is like kind of like recompiling the background. I'm just gonna move this out eventually. Can I just run this myself? Yeah. Okay. All right. So let's take a look. Fertilizer to water. 49538. Is that right? Fertilizer to water. 49538. 01142. Okay, perfect. So now we get our ints. So our map is all set up. So now, what do we do next? Okay. Well, now we just got to process it. And let's go back and look at the objective for a second. So any systems aren't mapped, so we gotta remember, if we don't find one, then it's just its number, and we move on to the next stage. So this is where things get tricky, because we go from seed to soil, from soil to fertilizer, fertilizer to water. Okay, so this is our steps. And we want to end wherever the location is. Okay, so here are our steps. We're not going to score inside here. because that doesn't make sense. But what we do know is for seed in range of seeds, okay, that's where our score is going to come from. And we can do score plus or equal. And we're looking for the lowest one. So what we can do is if score equals 0, score equal score, and for our score we're going to input the seed and the maps. Okay, cool. We'll get to that function here in a second because I think it'll be helpful. We might create a test for it. I'm not really sure. Let's do TS as this, which is our temp score. We'll continue and we'll say if TS greater than score, TS score equals TS. Okay, so this just ensures that if it's greater than, we'll do that. All right, that works well. Score equal, if I knew how to program it in Go, I'd be fine. Score, so last thing, this becomes seed, which is an int, and then the maps, which are a map of string, slice of int. All right, so now the last kind of piece to this puzzle is we need to process them in that specific order that I mentioned. So here's an example of what we need to do. So we know we have a seed and we need to go to the soil. So what does that mean? We're going to do a soil equal to get. We're going to do another method because I think it'll help us just logically break it apart. So we're going to say get dest, and we're going to pass in the slice of int. So what we're going to need to do is we're going to need to do maps sub, and then really it's just we're going, so we need the seed to soil map. So if we go back to our seed to soil, okay, we're going to do seed to soil, and we are going to provide it with our seed. Okay, cool. And then we're going to do a func get dest, and it's going to take in a seed, which is the int, and it's going to take in the maps, or it's going to take in a slice of int, which we'll just call m for map for now, and we're going to return an int, which is the destination. So now we're creating generic kind of like methods here, and so what we're going to do is we're going to say for each for each map in mapping. So what we're going to do is we're going to say if m sub 1, because that's our destinations on the left, our sources on the right, okay, plus m, or if m1 is less than or equal to, because that's our lower number, less than or equal to seed, and seed is less than or equal to m1 plus our range, which is m2, right? Then we're going to return our seed minus m1. So that'll be like our 79 minus the 52. Okay, which will give us our difference. And that is going to be m0, which is our destination, plus whatever our difference is. Only if we find this match that's true. Otherwise, we return seed. This shouldn't be called seed though. It should be called source in this context, which is seed for the first example. $81. Okay, so is that true? Let's go and look at our example. 82. Ah, no, it's right because we only did the first one. Seed 79, soil 81. Okay. So now that's correct. I probably could write test from, but I didn't. So here we are. So soil, done. And then what do we have? Let's go to our test input. Let me grab these. Okay, let's put all these right here. Fertilizer to water, temperature, humidity. Okay, so I think this is the same order that they need to be processed in. So what I'm gonna do, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Soil, fertilizer, water, light, temp, okay. So then we can copy, go down one line, right? Temp to humidity, so on and so forth. All right, let's do it. 35, actual 86. Well, we want the lowest number. There we go. Ha, okay, cool. So that should be the one in the books. Let's give it a shot. Oh, what did I not do? Oh, input text. Okay. Boom. There we go. All right, on to part 2. Part 2. Everyone will starve if you only plant such a small number of seeds. Rendering the almanac, it looks like the seeds line actually describes ranges of seed numbers. The value of the initial seed line comes in pairs. Within each pair, the first value is start of the range and the second value is the length of the range. So in the first line of the above example, this line describes 2 ranges of seed numbers to be planted in the garden. The first range starts with seed number 79 and contains 14 values. The second range starts with seed number 55 and contains 13 values. Now, rather than considering 4 seed numbers, you need to consider a total of 27 seed numbers. In the above example, the lowest location number can be obtained from seed number 82, which corresponds to soil, etc., etc. So the lowest location number is 46. Okay, well, that's not too bad. Same kind of problem, same kind of efficiency thoughts here. So I could just do an I iterator from the, I know we've got number 79 and we need to check 14 other values. Right, so the second number is the range. So that's a lot. It's a lot. So do we just brute force this team and call it a day? We can try it and see if it's efficient enough. So there's two approaches. One is we could just do a 4i iterator from beginning to end and process all those values. Okay, I see why it changes the number, because we're going from, instead of 14 being a possibility and 13 being a possibility, it's 79 plus between 79 plus 14 to plus 13, which means our lowest possibility based on the mapping is 82, location 46. I really don't want to try to do all the math like possibilities in my head of not iterating through each one, and I'm not sure that would even necessarily be any faster because you're still doing all the same comparisons anyway. So we'll create a part 2. Somewhat unfortunate that I need to create a part 2 for this. I don't want to duplicate all this. Okay, so we can do seeds, maps, build, maps, boom. All right, cool. And this needs an input. Okay, got it. We'll give this S. Okay. And great thing, hey, we wrote a test. Still works. Great. Okay, so now part 2 is the same, except it's not. This becomes a little bit more challenging because instead of ranging over the seed, what we're going to do is we're going to say for I equals 0, I is less than length of seed, and I plus equal 2. I think that will work. And so what we're going to do is actually increase by 2 every time. So that way we go from 0 index to 2 index to 4 index, etc. And we're going to say that for j equal to seed sub I plus plus, or I'm sorry, j is less than or equal to seed sub I plus 1, which will be our second position, and then j plus plus. Okay, so what that's going to do is it's going to make sure that this is seeds. It's going to iterate by 2, and then it's going to use the start and end range. Oh, but this has to be our start plus our end range. And then from there, I think we just do this, which our seed is going to be whatever j is. Yeah, so this goes away. We don't need this in either of our 2 examples anymore. We'll go ahead and prep part 2. Do we just do it? Nah, let me create a part 2, homie. And then our test result 46, Done. All right, let's run it. I was worried that might be a problem. All right, well, why this is running? Because it's still running. That took a really long time. And it's wrong. Let me read through this again. Line describes 2 ranges of seeds that were planted in the garden. Range starts with seed number. Second range starts with 79 plus 14. .93 contains 14 values up to 92. That's the missing problem here. Is it's not plus, it's -1. We'll solve that and then let it run again for a really long time. It really wasn't that long, but it's long enough for me to not like it. Seed plus seed -1. Okay, and then let's rerun. I made a mistake, I think, with this also. So when we get the destination, it is the M1 plus the M2 -1, because again, I missed this one key fact that it does not include the last value, or we could rather switch this both to this here. So let's fix that, and let's just go ahead and change this as well. It's exclusive and inclusive. So if we run this again, I think we're still going to pass, and then we'll go ahead and execute this and hope for a different value. That should do it. The rule that I missed is this here, where it was contains 48 values, so it's 50 to 97, and again, our test case didn't include that, nor did problem number 1 include that. I ran into problem number 2 here, so this should do it. Also, again, not greatly efficient, so I will probably come back and revisit, but let's get this thing knocked out. All right, let's see if we got this solved. This is a different number. I think it's 1 value lower. Oh, got it. Okay. Man, what a bug. The details matter. They always matter. All right, awesome. Well, we completed day 5. It's an exciting time in the advent of code. That one little edge case had me off kilter for a little bit, but we're good to go. I look forward to seeing you guys tomorrow. Y'all have a good night. you.